In this video, we're going to find the product of multiplying two binomials against each other, and we're going to use an area model to demonstrate this process. For some of us, it's going to be easier to use a geometric method, such as finding the area of a rectangle, to understand what the product of two binomials is going to look like, rather than using an algebraic method like FOIL. So in geometry, one time that we are going to multiply two terms against each other is when we're multiplying the length and the width to find the area of a rectangle. So the two binomials that we're looking at is 2x minus 3 in parentheses multiplied by x minus 5. Now what we're going to do, keeping this all color-coded, we're going to set the length equal to 2x minus 3, and we're going to set the width equal to x minus 5. So with the rectangle that we've got down below, I'm going to take 2x minus 3 and label that as our horizontal distance, and I'm going to separate these terms. So we've got a positive 2x minus 3. I'm going to put a space in between those two terms. And then our width is going to be a positive x minus 5. Now, the reason why I spread these terms out is so I can separate them. Now, we've got two terms on the vertical axis, two terms on the horizontal axis, and we're going to create our area model. So I'm going to separate this one large rectangle into four smaller rectangles. And now what I'm going to do is just multiply length times width 4 times over. So we're going to multiply negative 5 times 2x. That's going to give us a product of negative 10x. Then we are going to multiply negative 3 times negative 5. That is going to give us a positive 15. And two more times on the bottom, positive x times 2x is going to give us 2 times x, and we can write that simply as 2x squared, and x times negative 3 will be negative 3x. So we've got our four terms in black, and now we're going to line them up in standard form, starting with the variable with the greatest power and moving on down to the constant that doesn't have a variable associated with it. So rewriting that all out, it's going to look like 2x squared minus 10x minus 3x plus 15. And you can see in the middle here, we've got two x variables that have an invisible power to the 1 right there. We can combine our like terms, and negative 10x minus 3x is going to give us a negative 13x. And then we'll simply drop our remaining two terms down and create a trinomial that is the product of our original two binomials. So the area model uses the area of a rectangle to demonstrate what we're doing when we multiply our two binomials together. Now, something you may be familiar with is the FOIL method. So we are going to look at this and one more time using the FOIL method. And the FOIL method is simply stated, we're going to multiply the first two terms together first. So here in blue, we're going to multiply 2x times x, and then we're going to multiply our outside terms together. And our outside terms are going to be 2x times not just 5x, but negative 5x. Let me annotate that right there. And then we're going to multiply our inside terms together. So it's going to be negative 3x multiply times x. And then we're going to multiply our last two terms together, which is going to be -3 times -5. All right. So once again, keeping it all color-coded, 2x times x is going to be 2x squared. Going back to the 2x times -5 is going to be -10x. And then in green, -3 times x is going to be -3x. Going back to the -3, -3 times -5 is a +15. And once again, we're going to combine our middle terms that have a single power of x, -10x minus 13x. That gives us -13x. Drop down our remaining two terms, leading with 2x squared minus 13x plus 15. And we've got the exact same trinomial using the FOIL method. So geometric method on the left using the area model, algebraic method on the right using FOIL. Hopefully one of these makes more sense to you than the other, and you can relate to that and visualize what we're doing when we multiply these two binomials together.